Welcome everybody. Thanks for showing up, basically in the evening, right? Here, this time we actually start on time, so that's a positive change for a start. Let me actually quickly check who has been with me in the earlier session today, the 4.3 session. Inverse question, who has not been to the previous session? All right, a few. I hope that there's not too much that's missing for the ones not having been there. I'll do a quick recap on the 4.3 roadmap initially anyway, so we will connect the dots for you so for that to work out. But fundamentally, this is a preview talk. So I'm going to talk about things in contrast to anything else we talk about, which are not quite there yet. In Springland, we tend to talk about things that are already available or in the immediate process of being available, like 4.3, take the latest 4.3 build snapshot, and you basically get almost the entire feature set, and RC1's just 4 weeks away, right? That's what we normally do, talking about things of immediate relevance that you can have in your hands for production use in either right now or within 2 or 3 months, right? This presentation is different. I'm talking about a generation of the framework that is scheduled for general availability next year, early 2017. A release candidate in December, right? So quite a while away. But we'll get to our roadmap planning in just a bit. All right. Before we get started on 5.0, I will do a quick 4.3 recap because fundamentally they are part of the same plan. In just recent planning exercises, right, like even middle last year, we were wondering how to proceed from Spring Framework 4.2. So this is actually not a given, right? We make up our own roadmap. We don't really get a roadmap laid out to us by anyone, right? So we very quickly arrived at the need for a JDK 8+ based generation, a Spring Framework 5 plan, just to have a vague target to work to. But it also became very apparent that we want to do a Spring Framework 4.3. And 4.3 is designed as a last feature release in the Spring Framework 4.x line. Essentially, this is connecting a few of the remaining dots. It wraps up many refinement themes that we already have as kind of ongoing themes in the 4.x line. So in many ways, it completes the mission that Spring Framework 4.0, 4.1 set out to go for, right? In particular, Spring Framework 4.0 came up with a lot of things, right, from WebSocket support, the messaging package, the refined injection matching algorithm, the composable annotation model, many of the things that have been started basically with an 80% feature set in 4.0 are achieving their final destination, right? With 4.1, 4.2, we are almost there. With 4.3, we wrap up the last spots in the framework where you can't compose annotations yet. We fine-tune the injection matching algorithm to the few remaining cases that have been around for a few years on our issue tracker and have still not been tackled. So I'm going to just give you, and for those not having been to the afternoon session, I'm going to give you an example or two of what I mean by this. But from a roadmap perspective, the point is we can deliver Spring Framework 4.3 to you very immediately. The current goal is the end of May, and I don't see that changing. The RC1 is planned for the 3rd week of March, and a GA by the end of May. So everything talked about this afternoon, everything in 4.3 will be available in your hands very soon now, and basically suitable for production use as of the end of May. Our further plan for this 4.3 line is to make it into an extended support arrangement. To turn it basically into a kind of extended support branch, just like 3.2.x is right now. That's probably the best comparison, right? If you know where Spring Framework 3.2x is, 3.2.16, it's already in its 4th year of maintenance. It will see end of life towards the end of this year. 4.3 will be put into that position, into a similar position. There's the GA. There may be a few refinements in 4.3.1, 4.3.2. From then on, it will see an extended maintenance phase up until 2020. No hard target there, just we don't really know yet how long there is demand for it. But our loose plan is to have a 4-year frame, just like Spring Framework 3.2 had. Keep in mind the system requirements. Spring Framework 4.3 still has a very broad range. JDK 6, 7, 8, and 9, right? Running on a servlet 2.5 plus container, which includes Tomcat 6, 7, 8, and 9 milestones. It runs even on WebSphere 7.0, a 2008 generation server. And of course on more recent ones up until to the recent 9 previews from WebSphere and the Liberty Profile and all those things, right? It has a very, very broad range. So keeping that in mind, 4.3 is our last chance to give programming model refinements to you in a JDK 6.7 compatible way, right? If we would restrict them to 5.0, you would only be able to run them on JDK 8 Plus and modern day infrastructure. So we also selected features which are easy enough to provide on a JDK 6 Plus foundation. To some degree, you can look at it like that, right? 4.3 is almost like a bit of a 5.0 backport release for JDK 6.7 compatibility purposes. This is the reason why there are some pretty significant refinements in 4.3 that you would otherwise only expect in a 5.0 release. So, in particular for those not having been to the afternoon session, just what do I mean by this? What I mean is the commented out constructor in this particular example, right? Otherwise a regular Spring Component class. But as of 4.3, a much demanded refinement is if there's a single constructor suitable for injection purposes, there's no need to mark it with @AutoWide or @inject anymore. A simple enough refinement, really. We just never did it, right? We never got there. And we generally advocate explicit demarcation. But imagine a different example, a different class, a class which otherwise doesn't actually have any Spring annotations because it's externally defined, maybe returned from an admin. Return from an admin class, you would actually auto-wire it directly, but XML defined, Groovy defined, picked up through component scanning, filters. It maybe wouldn't have any other annotations. So if auto-wired was the only annotation you had to use just for dependency injection purposes, right, then the problem becomes more apparent. It makes more sense to do things by convention than not with explicit annotations. So to some degree, we're addressing scenarios where annotations are rather to be avoided, not necessarily this specific class, right? So that's the sort of thing we do. This thing I've also shown this afternoon also wasn't possible before, right? To some degree, we are closing gaps in 4.3 for things you would already expect to work since 4.0, right? Where intuitively you would try those and they wouldn't work, so you kind of learned not to use them, but it doesn't really make sense that they don't work. In this particular case, a Spring configuration class with its admin methods, try using an auto-wired constructor on it, a constructor with parameters, right? Didn't work before. CGD subclass generation and the corresponding instantiation algorithm wasn't able to deal with it. As of 4.3, just do it. Like on any component class, put a constructor there, no need for a default constructor. Usually stick @AutoWired on it, but it actually connects to the data refinement, right? You don't need to have @AutoWired on it if it's a single constructor. So that's another refinement we do. And that's kind of in the DI space. In the web space, the endpoint model, typical Spring MVC control, actually no immediate refinement in here. There's actually a 4.2 thing, like our cross-origin support, but it's a little bit more subtle what we're doing here. Now, this syntax has been around for a while, but even this particular example is actually very up to date. The path attribute is only there since 4.2. Previously, it was named value in order to not have to specify it if it's the only thing you pass to request mapping. And cross-origin is 4.2 specific as well. As of 4.3, cross-origin is going to be refined a little, for example. It will support placeholders, that sort of thing. Consistent placeholder support is another thing in annotation values that we aim for in 4.3. But The main reason why this is here is another refinement is variations of mapping annotations. So we consider doing those things also as shown in the afternoon. Get mapping, post mapping variants in immediate comparison with the previous one. Those are just composed annotations. You could say like specialized versions of the other annotations, meta annotated with the others, right? There's also REST controller on the second one. REST controller is already around for a while, since Photo even, if I'm not mistaken. REST controller says add controller, add response body, right? It just composes those two annotations. You could create those on your own easily. And get mapping and post mapping follow the same idea. Just meta annotated with request mappings, hard coding the method. And the primary goal is subtle. If you look at this more closely, what's the biggest benefit of this variant? It's actually not having to specify annotation attribute names. No path equals, no method equals. If an annotation has a single attribute to specify and declares a value attribute, right? Then the Java annotation rules allow for this shortened syntax. Just pass in the attribute. No need to say value equals something or path equals something. That's the nicest thing about get mapping and post mapping from my perspective. Put mapping, patch mapping, delete mapping. They indicate the HTTP method in the name and typically only accept a path or a path pattern to be mapped to, which then doesn't have to be qualified with an attribute name. A little bit of a subtle benefit, right? Maybe not immediately obvious, but that's the sort of goal we have in our refinements at the moment. We've done this for other annotations already. We did this sort of stuff here, even for portlet support, a long time ago. In Spring's portlet support, there's like action mapping, render mapping, resource mapping, event mapping, sub-annotations, basically, of specialized annotations, variants of head request mapping. This follows the same idea, fundamentally. Finally, doing this for RESTful endpoints. A little bit of a debate going on at the moment about this. It doesn't matter. The point here is we are doing those things for Photo 3 because they are low-hanging fruit. We can easily do them. I mean, those are very simple annotation declarations that you could do on your own in 5 minutes. More like 2 minutes. If you wanted to, right? We just decide to ship them out of the box. Technically, very simple to do in the Photo 3 generation. So we decided to make up our mind now. So those things we are not dragging out, but we intend to kind of decide, do we do those? How do we name those? How do we fine-tune those? We will decide in the Photo 3 timeframe going up until May. Right, so much for a little bit of a different perspective maybe on why we do those things in Photo 3 instead of just what we do. Now, for 5.0, we don't actually have a branch yet. So, advance warning, you're not going to find a Spring Framework 5.0 branch on GitHub. There is none, right? We're not hiding it from anyone. We simply don't have a master branch for it yet, because some of those efforts are being worked on in feature branches, more specifically actually in the reactive part in an R&D sister project on GitHub. So if you're interested, I have the link on the slides later on. There's a Spring reactive project on GitHub with different characteristics, an R&D project, not to be taken for granted as is. Anything may change there, including the package structure in particular. But we're not far from merging it into a proper Spring Framework 5.0 master branch that's planned for June. So it's about 3 to 4 months away, mid-2016. So much for just an advance warning. So at this point, we talk a little bit more about stuff that we are going to work on, where we're currently designing more than implementing. So, the three main themes for 5.0 are JDK 9, fundamentally. Very essential for us to pick up new JDK generations as they appear. I will add some details in just a minute. We do strongly believe that HTTP 2 is among the most important things this industry has to pick up quickly, not sometime in the future, more like now or at least next year, right? So we have a strong focus on HTTP2. Actually, some of it is in 4.3 already, but the comprehensive version comes in 5.0, and Servlet 4 support comes along with it. And the reactive story, we are going to spend the remaining time of this session on it anyway in more detail. I'll lay out the current design implemented in the current prototype for you in just a bit. So, timing-wise, we aim for a generation of the framework designed for the challenges of 2017 plus. So we intentionally are more aggressive than usual in our baseline upgrades, for example, in the system requirements, in the minimum dependencies. The plan is actually to remove everything that's marked as deprecated right now. So everything that's marked as deprecated in 4.2 in particular is just going to disappear. Actually, the plan is even more aggressive than that. Everything that will be marked as deprecated in 4.3 is going to be gone in 5.0. So we even reserve the right to deprecate additional stuff in 4.3, which is still to be removed in 5.0. The baseline upgrade, if you notice carefully, in particular Spring, in terms of Spring's history, goes JDK 8+. Now, Spring Framework 4.3 is JDK 6+. Where's the JDK 7+ generation of the framework? There won't be any. We are going to skip JDK 7+. It's easy enough to extend the JDK 6+ support, right? But there's significant benefit in the JDK 8+ upgrade. A few details for the interested ones would, in terms of what this means for the framework internally in just literally a minute or two. The other baseline upgrades are probably more obvious. Servlet 3.0+ is overdue. I mean, we still support Servlet 2.5. Now look up the history when Servlet 2.5 was defined, right? So Servlet 3.0+ is the 2009 generation of the Servlet spec. In the 2017 generation of the framework, that's not particularly aggressive. JMS 2.0+ is out of E7. That's actually a 2013 era specification, but it's the first update of JMS since 2002. At this point, we support JMS 1.1, a 14-year-old API specification. It's about time that we get rid of this, right? JMS 2.0+ it will be. And we'll also upgrade the JPA and bean validation minimum, and probably most interestingly, JUnit 5 is on our immediate roadmap. You might be aware that we've been an integral part of the crowdfunding campaign. Pivotal was one of the early sponsors. We also have promoted the crowdfunding campaign, and we sponsor significant development time from our Spring Test developer, Sam Brennan, on JUnit 5. So this is very dear to our heart, and JUnit upgrade towards JDK 8+ is really overdue, and we'll pick it up immediately. Actually, there's already an ongoing JUnit 5 prototype being released with Spring support from day one. And in Spring Framework 5, there's going to be proper JUnit 5 support. We actually lobby for JUnit 5 to go final somewhat soon. Anyway, right, so we connect quite a few things here across our immediate environment around us. Spring doesn't live on its own. It was always a key part of our mission to pick up-to-date infrastructure around us. Right, so let's move on to the infrastructure themes, as mentioned before. The baseline. So a little bit wordy here, but I'll give you a different spin. Fundamentally, the question is, what benefit do we get out of raising the framework baseline to JDK 8+? I can tell you one thing up front. For you as application developers, if you take an application developer's perspective, it won't make that much difference. Because Spring Framework 4.2, 4.3 give you everything technically possible in terms of supporting JDK 8 structures, artifacts, APIs in your code already. We do this conditionally. If Spring 4.3 runs on Java 8, it knows how to do all the Java 8 things if appearing in your code. It knows how to support Java util optional, Java time, stream conversion, those sorts of things, right? So you can already do everything, basically almost everything possible in your code, and the framework reactively supports those Java 8 structures. But at this point, of course, supporting JDK 6 and 7 in the same branch, The framework internally is JDK6 based, and just in specific places can refer to JDK8 APIs and so forth. Raising the Java 8 baseline allows us to internally do things we weren't able to do before, like use lambdas, use try with resources blocks, because JDK 7. Some things that are a little overdue. We can use default methods in our own interfaces. That's actually, from my perspective, the biggest limitation we have to live with at the moment. Spring's core interfaces take JDBC operations, REST operations, or even Bean Factory and application context. Those interfaces, statically typed, hardly typed. We can't use Java 8 artifacts there. We can't expose Java 8 API. There's no option of having an overridden, an overloaded variant with Java util stream or Java util function interfaces or Java util optional in there. We can't do that because the interfaces need to remain JDK6 compatible, the core contracts. And we can't use default methods. So the use of default methods here is probably the most important part. Evolving our own interfaces, we currently have to add new methods, which means everybody implementing or decorating those interfaces needs to implement them. Or we try to be somewhat smart, we create an extra interface, a sub-interface of the existing ones, adding the additional methods. That's always been a bit of a pain. It was kind of doable. We became somewhat good at it, I suppose. But we look forward to be able to declare, in particular in our callback interfaces, to declare default methods. Now, callback interfaces often have like at least 2, sometimes 4, 5, 6 callback methods. But if you're implementing one of those callbacks, you might only have to override 1 or 2. You typically stub out the others. With default methods, there are just no-op implementations in the interface itself. No need to provide any base classes for it. Right? So those things are what we are looking forward to. I admit it's primarily for the framework implementer's perspective. It's also important for the integrator's perspective, for third-party extensions to the framework, right? And to some degree, but to a minor degree, it's also going to provide benefit to you for application use. So there might be overloaded versions of methods in REST template, for example, or in other library-style classes in the Spring code base. Finally, exposing stream or declaring optional variants or returning completable features in a hard way without having to adapt or cast anything. But the benefit is somewhat minor. Basically, you get everything that's typically needed out of 4.3, but we don't as framework implementers, so that's when we catch up. All right, and it's an important enabler for whatever follows. We do need this for new APIs we're defining, for refinements that we have in mind for other purposes. We need to be able to refer to Java 8 types, artifacts, and default methods for anything we're doing from that point onwards. So it's an important step to take to allow for further evolution, further innovation in 5.1, 5.2, and so forth. All right. So maybe that was a bit of a background perspective. Now let's pick up some more mainstream stuff. JDK 9 is also due next year. Now, the plan says it goes out in the 4th week of March next year, like the plan on the OpenJDK website. We currently work with an assumption of that actually happening. So our plan is to kind of align the Spring Framework 5.0 schedule with the JDK 9 schedule so that we can build against a GA JDK 9. We aim for comprehensive JDK 9 support in Spring 5. That means quite a few things. It in particular means support for the module system for Jigsaw. There's quite a bit of thinking and discussing already gone into this one. We reported a couple of limitations to the Jigsaw guys already, so I'm the primary reference there, talking to like Mark Reinhold and Alan Bateman on the Jigsaw team to get a few things that we would really like to see or actually almost need, like optional dependencies. Right, Jigsaw is a little hard to tell how much impact it will have on our way of deploying applications. We personally, I'm super interested in just the basics of a module system, right? Some runtime information, reflective information available to the JVM, but also to frameworks about the structure of the application. There can be many benefits to this: optimizations, caching, isolated scanning of just a module, symbolic module names that you can use to refer to when expressing dependencies or when monitoring your application. So the basic arrangement in Jigsaw is actually somewhat down to earth, right? Basically, it's not at OSGR's complexity level. It's more like a fundamental decomposition of the good old class path. Getting rid of this awfully long text string that is the class path, replacing it with a module path. A module path which is more like a tree, or a graph, right? Instead of this completely flat arrangement that is the class path. We see benefits in Spring. I'm going to show you just a sketch of what this can look like in a bit. At this point, it's not only about Jigsaw. There's other stuff in JDK9 to pick up, like a new HTTP client planned. Finally, a replacement for the good old HTTP URL connection, HTTP2 capable. Also shipping the ALPN stack needed by the basically SSL support in HTTP2 will be in JDK9 out of the box, so containers using it or any libraries using it won't have to ship their own version of it. So, and there's actually more stuff. Java util concurrent refinements, Java util concurrent flow, we'll revisit in a bit. Right, so just a few further thoughts on Jigsaw. What can this mean? What we would like to be able to deliver is an application experience along these lines. That as an application module, you would include a module info, because in Jigsaw there's a module-info, like package-info, basically a Java file with special language in it that can be compiled with the regular Java compiler and will be included in your jar files. A pre-compiled module dependency piece of metadata, basically. But not textual, it's a compiled effort. The current syntax looks like this, right? It's kind of a module structure, like a package declaration, module declaration, and you refer to other modules that you'd like to depend on, where you insist on them being available when you start, but also that you'd like to see, that you'd like to have access to. Then you would say like requires and the symbolic name of that module. Requires java.sql is currently what you have to do to refer to JDBC in the Jigsaw prototype. And for example, if you're using Spring JDBC with it, you would say requires spring.jdbc, the symbolic name for the Spring JDBC artifact. The current proposal, or at least the kind of assumptions made by the Jigsaw team, are along the lines of those names kind of following the Maven central artifact names. So spring-jdbc would currently change to spring.jdbc. It's in discussion whether this dot syntax remains. Some people complain it looks too much like a false package name, which it isn't, right? It isn't a package name. We'll see, right? From a Spring perspective, I would be perfectly happy with this spring.jdbc syntax. It might even be better than that. You might not even have to say requires java.sql, because if the Spring JDBC module is able to re-export, kind of transitively export java.sql internally, you might even just have to say requires spring.jdbc, and you implicitly get access and visibility to java.sql along with it. It might be a pretty nice experience. Now, this is JVM level information. This is not your Maven POM, right? So how this interacts with your external tooling, like the Maven POM not only having this information, but also having version information in it. Versioning is currently not in the feature scope of Jigsaw. It's just decomposing the runtime structures and enforcing visibility boundaries. This is what Jigsaw is about. Doesn't do versioning, doesn't really do provisioning, doesn't know anything about repos. But obviously there's alignment, well, necessary almost, but at least desirable. We would like to have kind of a Maven POM arrangement where this information can be represented in module infos, not necessarily repeating yourself, but taking it from a single source, maybe, well, can be both ways, right? It's up for the IDEs to really make up their mind, up for maybe Maven and Gradle to sort out how to do this. This is basically information that can largely be derived from maybe other dependency information sources that you have in your project already. We'll see. For our purposes, this doesn't really make a difference. In Spring, we would like to ship the framework modules and the entire Spring ecosystem around it eventually with explicit module data, well-defined symbolic names, well-defined requires statements and re-export statements, so that if you choose to use Jigsaw for your application purposes, the framework is a first-class citizen in that arrangement and basically allows you to use Jigsaw to the best possible degree. Keep in mind, early stages, right? Jigsaw's not even in the JDK9 snapshots. Still in a branch, kind of, with special purpose snapshots generated, which are not in the main line. Things may still change. And very recently, basically just yesterday evening, there was an email on remaining discussion points for Jigsaw published on the Jigsaw project website. Quite a bit to go through still. But I'm glad that it's at least a prepared list and kind of almost a statement of things to work through. I'm glad we are at that level already. All right, so much for a little bit of jigsawing. I would actually also like to maybe discuss a few further things out of JDK9, but for the purposes of this presentation, I'm just going to sneak a few JDK9 references in after the fact. Because there's a very important topic I've already expressed my opinion on, HTTP2, super important. I mean, these kinds of protocols are what this industry is about in the end. If we don't get our act together in supporting those in a timely fashion, we have a problem. And I particularly mean the Java world, the Java ecosystem. If it's nice, right? If Chrome and Firefox, even Safari and Edge and Internet Explorer 11 support HTTP2 on the browser side. I mean, it's kind of cool. But if our servers don't allow for the use of HTTP2 on the server side, what benefit does it bring, right? I mean, it's if we use our browsers to use Gmail or Google Maps or Twitter or whatever, we kind of know or can assume they work with HTTP2 in the meantime. But our server applications that we build with our Java server stacks are typically not there yet. So, from my perspective, this is something to be embraced. Not because it radically changes our application development models or even our internal server architectures, server application architectures that much. It is just a more efficient communication arrangement between HTTP-based clients and HTTP-based server applications for quite a few reasons, right? In particular, binary formats, headers compression, multiplexing on existing communication channels. Server pushes, statistically derived. There are a couple of really nice effects in there. More efficient arrangements than the outdated 1996-based HTTP 1.1 ever was able to deliver. And it's a way to get rid of workarounds, but that's a topic for a different presentation. So HTTP2 is really something to embrace, not just something to wait for until it happens magically. We need to make active steps towards it. Right, active steps, quite a few of them are already happening, or at least in the process of getting there. Servlet 4.0 is currently aiming for mid-2017. I say currently aiming because there are no guarantees. It's just a very rough target date. The date is not even as hard as JDK9 is. We'll see, right? But Servlet 4.0 made some good progress already. The early draft, the corresponding API jar is already available. But fundamentally, Servlet 4.0 is a revision of the servlet spec enforcing support for HTTP2 from all servlet containers. What I find more important at this point is that there are already servers trying to do the best they can based on the existing infrastructure to support HTTP2. And this is actually in quite good shape already. I mean, as good as it can be given the limitations. JD 9.3 is spearheading this effort, right? This movement. JD 9.3 has out-of-the-box HTTP2 support basically to the degree that you could ask for. Recent undertow generations, strongly, that's the web server within Wildfly, but also available standalone and supported standalone in Spring Boot, for example, is already HTTP2 capable. And in the upcoming Spring Boot generation, Spring Boot 1.4 goes along with Spring Framework 4.3. We are already considering to expose this in a more first-class fashion, the HTTP2 support in JD and Undertow. Tomcat already has 9.0 milestones and is also aiming for HTTP2 support and servlet 4.0 support. In Tomcat 9, this is actually part of the problem. The others don't aim for servlet 4.0 yet. And the plan in Tomcat land currently, no guarantees ever, but the current plan is there will be a Tomcat 8.1 somewhat soon, backporting the HTTP2 support to the servlet 3.1 based generation of Tomcats. Because Tomcat 9 will only go final once servlet 4.0 goes final, which can be way into next year. Actually, even very far away at this point still, right? We are aiming for providing HTTP2 based solutions to the degree that we can, right? In the Spring Boot arrangements and everything around us, all the infrastructure around us this year. That's the goal, and unfortunately that means we can take servlet 4.0 into consideration, but fundamentally we need to focus on the native support in the servers that allow us to do it. Spring Framework 5.0 aims for a more comprehensive story. Servlet 4.0 based, well, servlet 4.0 supporting, right? Spring Framework 5.0 requires servlet 3.0 and works with 3.1, of course, as the main branch that we find out there in production, by then at least. And servlet 4.0 we will support to the degree that we can. So we are going to support the push builder mechanism in there, maybe stream prioritization. We're going to expose it in the Spring Web Endpoint model in Spring MVC to the best possible degree, which we're not doing right now. In 4.3, it's just about HTTP2 runtime infrastructure, no direct exposure to applications yet. Now, kind of connected to it a little, let's talk about our reactive programming efforts in the remaining time that we have. The Reactive Manifesto kind of kicked it off with kind of a statement, right? A couple of people, a couple of stakeholders in the Java ecosystem getting together and defining goals, characteristics that we would like to aim for, at least, right, in our application architectures, with the support of modern day infrastructure. Reactive interaction is more than just asynchronous processing. Asynchronous processing is possible right now. If you use Spring MVC 4.2 on a servlet 3.1 container, you can take it pretty far. Even on a servlet 3.0 container, you can get pretty far in just taking an HTTP request and kind of spinning it off to some other thread and letting it do its job, letting it wait for something to happen before it actually continues generating the response. Reactive is a little bit more than that. It's in particular about back pressure, reacting to the ability of a client, of a kind of communication partner, to continue processing, right? You don't just process and generate stuff, not in your main thread, not in an asynchronous thread, worker thread either. You react to signals from your client communication partner, whether you're actually supposed to do this. And in the meantime, you kind of disappear, use as little resources as possible. So reactive is a couple of principles combined, I would say, which unfortunately requires a rethinking of our underlying infrastructure. Some of this thinking coming out of the Reactive Manifesto has been already put into a very concrete arrangement, the Reactive Streams specification, which is actually not really a spec. It's more like an API jar. The API jar contains just a couple of types. It's a very minimal API focused on back pressure-driven interoperability between infrastructure components. Keep in mind, this is not necessarily application level. Actually, I would argue it's not, right? These are interoperability concerns between HTTP servers, frameworks, data store drivers, everything involved, right, in a typical I/O processing arrangement. So Reactive Streams as a spec in the org.reactive streams package is intentionally minimal. And it's so minimal that it actually is being repackaged as a single type with a couple of nested interfaces, basically, in JDK 9 called Java Util Concurrent Flow. Those are the same interfaces, so any type implementing the Reactive Streams types, the external ones, could also just by its signature implement Flow or adapt to Flow very easily. And unfortunately, it's in a different namespace and slightly different structure, but exactly the same purpose, exactly the same capabilities. In the reactive space, there's a lot more to digest these days, right? From an application level, or if you look at typical application examples out there, if you just Google for how do I do reactive programming in Java, you'll end up with some RxJava examples usually. We are at the level of reactive extensions, composition libraries, allowing you to express basically an entire processing chain, an entire processing arrangement with rich operations for combining several tasks, for rearranging certain data structures. That's what you get in more application level libraries like RxJava, like Reactor. Reactor actually coming out of Pivotal, so being very close to us. The current lead of Reactor is actually one of the drivers of our Spring Reactive R&D project. So Reactor is very close to us. That's Reactive Streams. And it's the foundation for what we're doing. Then it's part of the motivation of why we're doing it even. What we aim to deliver in Spring Framework 5 is a Spring MVC-like endpoint model based on a Reactive Streams foundation. It basically delivers the common Spring MVC endpoint style. I'm going to show you a few preview examples in just a slide or two. The idea is that we take the established Spring endpoint arrangement, right, what you're used to, controllers, handler methods, request mapping annotations, to the degree possible, the best degree possible. We're going to reuse those for a separate engine running on a reactive stack. This is not a refactoring of Spring MVC. It's actually a separate web stack with differing characteristics, differing semantics in some cases, some limitations, different trade-offs, right? It's not based on the servlet spec, on servlet containers. It can be adapted to servlet 3.1 based servers, but not very efficiently. The most efficient variant of running this sort of arrangement is on a server, on an HTTP engine with native reactive support. So currently, in the prototype, we support Netty, we support, well, Gradient to the best degree possible, Tomcat through the servlet 3.1 adapter. So we do the best we can. We actually in the process of convincing the Tomcat guys to introduce a proper reactive interaction API, so that as of Tomcat 9, there will be a native channel to talk to Tomcat. No need to go through the servlet 3.1 async streams. This is on GitHub, so it's an R&D project, not a supported Spring portfolio project yet, but it's about to be moved to Spring Framework Master when that branch gets created. That's one of the first things we'll do is to merge that R&D project in. This is planned for June, and 5.0 M1 will go out mid this year, late June, early July-ish at this point. So, what could this look like? Actually, literally, what does this look like at the moment in the current prototype? This is a reactive web endpoint. Using at controller, regular class, Spring managed bean, request mapping associated with it, but look at the signature. I mean, this is a little bit of a dumb example, but what does it do, right? It uses RxJava for those ones wondering, right? Observable in this case comes from RxJava. It takes an observable of person, which is kind of a a kind of reactive stream, you could call it. Although the terminology is RxJava specific here, coming in, and our implementation says, now let's take this incoming stream of persons and basically map it to another stream of persons that we're returning, where we uppercase all the names. So not particularly real life, right? But in the end, that's what it's about, an incoming stream and an outgoing stream, a reactive composition library in between, expressing your algorithm, your processing algorithm, right? Your data manipulations through a reactive composition API, and leaving the rest up to the framework, to the infrastructure. The framework understands the signatures and will do its best to pass an actual back pressure driven observable in from the incoming HTTP request stream, and to manage the generated HTTP servlet response in an equally reactive way. So imagine this running on Netty. It's a completely different runtime arrangement when you compare it to a servlet container, but syntactically it's actually not that different. We can't abstract it, right? So just to take that maybe a naive assumption away, there's no way of magically getting reactive benefits from existing MVC controllers. The best thing we can do is to let you design things in a reactive way with existing elements like request mapping controllers, handler methods, existing structures known from the general Spring programming model. So that was RxJava. What would this look like in Reactor 2.5, the current generation of Reactor? Very similar, actually. The equivalent of observable is called Flux. Never mind the name, right? This is basically a sort of stream of persons, a back pressure-driven stream of persons. You take the flux of persons that comes in, you return an outgoing flux of persons. Actually, the implementation looks almost the same because Flux also has this sort of map operation, just like RxJava does. We currently reflectively adapt. So if you declare RxJava signatures, we know how to process those and to convert those. If you declare Reactor, we actually natively support those because our stack underneath is based on Reactor internally. Right, that's more of a sketch, but kind of delivering a particular point. This is a reactive web controller talking to a reactive repository. There might be a data store underneath that you support in a custom repository implementation of yours that is able to consume a Reactive Streams publisher, like a Flux here. Flux, actually, those types, you can't see it here, but they naturally integrate with Reactive Streams. They derive and expose the Reactive Streams publishers and subscribers natively. No need to adapt them, right? So you can pass it on to a repository. The repository may declare its signatures, maybe just on Reactive Streams, on the plain interfaces, not on the rich Flux. But in any case, the point is, an incoming HTTP request is back pressure driven. In your endpoint, you just pass it on to an underlying repository, which maybe passes it on to a data store driver. The data store driver is also back pressure driven and very efficiently allows you to react to incoming data from the data store. You are not blocking. These are entirely non-blocking arrangements. That's the goal. From the HTTP endpoint down to the data store interaction. In order to make this work, quite a bit of infrastructure needs to participate. But fortunately, some of those things are in the process of becoming available, or actually are already available in early versions. There's reactive support, for example, in Couchbase, MongoDB. There are even attempts in the Postgres database for a kind of reactive JDBC alternative. We need it in the data stores, because where are we blocking in practice, right? If our processing blocks, it probably waits on the database, on the data store, returning some data to us. So it's particularly important to have reactive drivers there. We also need it, of course, at the HTTP level. There's no point in having such an arrangement if one of the two is missing, really. Well, there may be benefits even then, even against non-reactive data stores, but not to the degree that we are aiming for here. So reactive HTTP clients are another topic, right? if you have a programmatic client doing interaction with an external server through HTTP, you would also prefer the same efficiency of processing, not blocking any thread when there are no incoming data. There's network I/O in between. You might just wait until the server delivers something, or the network lets your data through, right? So it's equally important on the clients if the clients are also programmatic. And there's already some support in the modern day libraries, like Jetty's own HTTP client. Well, you can also use Netty for those purposes, right? There's already some work done. In Spring Framework 5, we would also like to wrap those efforts up with like Spring-style first-class APIs to use for those purposes. One further note before we wrap up here, Reactive Streams Commons is a kind of sister project of the Reactive Streams API spec. We're currently working with the guys at Jetty in particular, involving some people from Tomcat in the meantime, where we would like to have a common adapter for Reactive Streams publisher-driven processing on Servlet 3.1 as a kind of somewhat primitive async foundation. This can be done. It's not super efficient, but it's better than well, having no arrangement on servlet containers at all. This Reactive Streams Commons effort has a default implementation using standard Servlet 3.1 means, but it also has an SPI where the containers can provide a more efficient version if they are able to, right? Basically, you could imagine there's the servlet request. Dear container, could you please give me a Reactive Streams publisher corresponding to this servlet requests stream? Literally almost a get publisher operation. This SPI allows for that. If not possible, we kind of wrap the servlet 3.1 async input stream as a publisher. All of this in a canonical implementation out of the Reactive Streams Commons project. We actually have one in the Spring prototype. We kind of collaborate with Jetty in shaping it up towards common code in Reactive Streams that we can reuse. All right, well, so much for that, really. Thanks for following that tour. This was a preview, so bear with me that I can't really add much more detail at this point. We're also running out of time anyway. If you're interested in any of those efforts, follow the tickets that we have on our issue tracker. With the reactive efforts, follow the Spring Reactive GitHub project at this point. So this is already actively discussed also on our issue tracker quite a bit. To summarize, our 4.3 versus 5.0 arrangement, 4.3 coming end of May 2016, so just 2.5 months away, delivering much desired little programming model refinements as discussed on JDK 6, 7, 8, and even 9. Once 9 goes GA, it's actually, we're going to have a Spring Framework 4.3 maintenance release that's officially declared as compatible with it at some point. Still in the plan. Spring Framework 5.0, aiming for early 2017, actually more specifically, aiming for a release candidate this year still, December 2016. With JDK 9 preview support, basic Jigsaw support, a more comprehensive HTTP2 story, and our basically brand new reactive web stack, not just the web stack, actually also the underlying core abstractions for back pressure driven processing based on the Reactor project. All of this coming your way as a release candidate towards the end of the year, if everything works out. The GA timeframe is more like ideally March next year, aligned with JDK 9's GA. Anticipating a question, what do we do if JDK 9 is delayed? I've been asked several times. There is a plan B, right? Has anybody followed what we did with JDK 8? Remember Spring Framework 4.0 and JDK 8? JDK 8 getting delayed by half a year. What did we do? We released Spring Framework 4.0 nevertheless, with JDK 8 preview support against the latest JDK 8 release candidate build, 3 months ahead of JDK 8's GA. Nobody complained. Hey, we built this framework with a pre-released JDK, nobody complained. And we formally had JDK 8 production support as of Spring Framework 4.0.3, when JDK 8 was GA. So with JDK 9, I see it coming. It might be the same way. So we are not strongly tying ourselves to JDK 9 schedule. If it works out that those are perfectly aligned, then so be it. If not, we will not drop JDK 9 support. We will ship JDK 9 previous support, build the framework on JDK 9 nonetheless, and declare it production supported once JDK 9 is GA in Spring Framework 5.0 something, or 5.1 maybe, depending on the length of the delay, if there is any, in JDK 9. So that's our basic plan. There's also quite a bit of insight that I was hopefully able to deliver here in how we arrived at that plan, why we are doing those things, as opposed to just what we're aiming for, and how we go about our timing. So thank you for listening for a start. And if you're interested, I've already given you a few pointers. The slides will also become available somewhere, but just Google for Spring Framework 5.0 or Spring Reactive. We have a couple of blog posts already and the GitHub project. So there's a lot of stuff to dive into if you're up for it. If there are any questions right now, I'm happy to take them. This is the last session today anyway, so I guess it doesn't matter what the time says. Not really on. I can also repeat the question if you shout it my way.
I believe no need. So I would have two questions. First question is about reactive. Can you somehow explain how backpressure will work with what you've shown? Because I mean, what you've shown is quite easy to understand, but I don't see a backpressure there.
Thanks for the question. I admit that these examples are somewhat simple. If you have more complex processing chains, it doesn't look that simple anymore, right? The idea is that you're using a reactive composition library and you instruct it with callback-driven processing steps. And you leave it up to the underlying engine when exactly it actually invokes those steps. The Reactive Streams specification allows for interaction between a publisher and the subscribers, where on a subscription you can say, like, give me one more element, right? Give me a few more elements. I'm able to process them. So they can internally interact when to get new data and how much of it to get. And then the Reactive Composition library calls your code, basically, that map operation, or any more complex callbacks, to actually process what's available at the time. When nothing's available, because we block, because there's nothing coming, and we are waiting for I/O to do its job, there is no blocking on any thread, right? The underlying engine is built in a way where threads are only being occupied for actual processing operations. They basically go back to the pool when there's nothing to do at this very point. That's the main difference. So just imagine that in a regular web app, you're waiting for an Oracle database to return some query data to you. It can take a couple of seconds and you're blocking the thread for that purpose. These kinds of arrangements, they're not that complex really, but they allow the underlying infrastructure to not do that, right? To not block a thread just because of waiting for somebody else's I/O job. In that sense, it is somewhat simple, right? It is almost as simple as it is here, but take it for granted. Look at RxJava examples. The more complex and the more real life the processing operations get, it's not that easy anymore. Very callback driven, very nice with Java 8 lambdas, right? And with some of the Java util function core types, but so different from the way we are used to do things. You know, you don't write for loops anymore. No iterators, really. If you're already used to Java util stream, this doesn't look that radical. But if you come from a more traditional Java background, right? Java processing background, for loops, over 100,000 elements in one thread, doing I/O operations for each step, then this is a little bit radical.
I see. Thanks a lot. And
I hope that makes sense.
Yeah, it makes sense. I'm familiar with Java 8 as well. So, but I wanted to ask you about Java 9. You expressed quite optimistic view on this topic, but I heard different opinions. I heard, for instance, from one of the Spring co-founders. Don't quote me, I don't remember the name. It was on Devox in Belgium, when he was saying that, okay, if JDK 9 will appear in a way it expected to be now, Spring won't be able to simply work with it, because the only way, for instance, to work with SPI framework is working with service loader from JDK, which is and things like that. I mean, it provides quite a lot of limitations.
I'll keep the brief. You're probably referring to myself. I remember having had that conversation. Yes, we actually raised a lot of Jigsaw tickets, Jigsaw limitations with the Jigsaw team at Devox Belgium, and to this day we still face the same limitations. But I quickly mentioned that there was this document just yesterday or last night that they published on the Jigsaw website, where those items have been formally declared, including the stakeholders, and somewhat prioritized as basically things to sort out before Jigsaw goes anywhere near feature complete. So my hopes are high for that to happen. There's always needs to be a plan B. You know, if Jigsaw remains as limited as it is, the best you can do for the typical Spring application experience on JDK 9 is to keep using the class path. That's literally what I told Mark Reinhold. And obviously they wouldn't be happy if that was the outcome, right? We don't aim to be mean here. Literally, we cannot do anything about it technically if we don't get optional dependencies. We cannot deliver Spring Boot's auto-config experience without this particular rather simple feature flag. So the OpenJDK team understands those limitations to the degree that we can expect them to have in their plan at the moment. It will take some time for those things to reach a feature completion point. I'll be frank with you, it's in the evening anyway, right? So let's have a bit of a looser wording here. This is the main reason why, personally, I'm not so convinced that JDK 9 can go GA next March. Historically, there was always a long release candidate phase in the JDK, a long one, right? From the feature completion point to JDK 9's GA, it will have to be 8 months, maybe even more. That's just historically forecasting this for JDK 9. Now, take 8 months back from next March, right? They would have to be feature complete in June, July. I'm not entirely sure that's going to work out. That's why I mentioned we have to have a plan B. But the plan B doesn't drop JDK 9 support as mentioned, right? We're going to do the best we can on JDK 9 as of like early 2017, whatever state JDK 9 is in. That's a commitment I can make, quote me on that, right? But the best we technically can. If there are technical limitations that are still not sorted out, then yeah, we're trying to do the best, maybe work around it, whatever, right? But fundamentally, we work with them in sorting this out, but we don't control the process, right? We have to wait until things move forward in Jigsaw land.
Thanks a lot. Thanks for a perfect speech.
Oh, thanks. You're welcome. Any other questions? On Reactive JDK 9, anything else? Our ways of doing things? Anyone wondering whether Spring Boot catches up? Yeah, it will. Spring Boot to the dough, along with Spring 5.
I actually have a question which maybe relates more to those sub-projects like Spring Data and Spring Boot, but usual response is like if there is some community thing, like for instance it was Elasticsearch support for the most recent version, so it's like, okay, push requests are welcome. I must admit I'm not that advanced to kind of compose something and then push and occupy someone's time and so on. So it's like Elasticsearch guys are ready to help. I talked to some of them and it's just not clicking together, and I reported Elasticsearch module page being just not found.
Yeah.
No reaction was like for 1 month I stop checking and stuff like that.
I feel your pain there. It shouldn't be that way. I'm not sure why there's no connection between the guys at Elastic who promised to kind of help out here, but Spring Data operates in a way where it relies on those providers, largely the providers themselves, to help out in maintaining the adapters. Some of them are basically community modules where we literally don't have a committer on it ourselves. So that might be the reason why you're not seeing immediate feedback, but I can raise this with the Spring Data lead. I'm sure he's not happy about that situation either, but there are quite a lot of Spring Data modules, a lot of providers to integrate with, and unfortunately they are not all in the same perfect state. I admit that. By the way, there's an immediate connection here. Spring Data, reactive repositories, right? Reactive capable data store interaction. The Spring Data team actually ramps up for a Spring Data generation that is aligned with Spring Framework 5 supporting reactive repositories, as a side note. And the Spring Data team is not large, just a couple of people doing all those things.
And another thing is like, is there any effort on reviewing the documentation? Because some things are just not...
you mean like the Spring Framework documentation?
That too, and in particular, just example which pops in my mind is Spring Security, which when you go to that page, it's featuring in-memory authorization, which has pretty much no real-life value.
Yeah. That's on the Spring.io website, right? On the Spring Security project page on Spring.io, I suppose?
Yeah, exactly.
That's not the first time somebody complains about the state of the Spring.io examples. We try to keep the Spring Framework and Spring Boot examples very up to date, but there are some of the projects in Spring Security is not as well maintained there as it should be. I accept that complaint and will forward it to the one guy we have working on Spring Security. So just imagine why that could be, that the website is not fully up to date. The Spring portfolio is large, and there are lots of things to do. Sometimes we just forget about those things. And if there's no explicit ticket to follow up on, in particular, things just don't get there. So it might actually help to create a ticket into the Spring Security issue tracker on Jira, an issue, right, that says like, update the Spring.io examples. We actually do those things to ourselves, creating tasks on the Jira issue tracker. So just as a reminder, if you want to interact with the Spring project teams, the most direct channel is the issue tracker. Jira for most of the projects, GitHub issues for some of the projects. Just create those guys a ticket there. Maybe do a search first whether somebody else created it already, but you get the point, right? Everybody's human here, and it just helps if there are reminders. We take those tickets very seriously. At least in most projects, we have a pretty clean state in terms of our issue trackers. All right. Any other notes? Is there actually something going on out there that I'm preventing you from going to? I don't know. Anyway, if there are no further questions, then once again, thanks for your attention. Give Spring Framework 4.3 RC1 a try once it's out. And if you're interested, just get in touch with some of the Spring Framework 5 efforts towards next year. All right, thanks. Good night.